this is why you always double check to make sure that you're live. Because I just went through this whole spiel for the last 7 minutes. Wasn't even live. So let's double check to make sure I'm now live. Because this is my first day. Quack, quack, quack. Do you know that reference? Wasn't even live. Okay. So we have some audio. We have video. Gotta go through spiel all over again. So this is going to be kind of a quickish live. I'm going to try to get through the remainder of the video that we started the last time. I'm going to do my best. I've been up since like 4:30. It's my first day back to work since vacation, plus first day of, well, technically second day of school, but the first day of school that I actually worked on it. Got a class done already for the week. My brain is mush. I'm going to do my best. So we're going to try this. We're going to try. No guarantees, but we're going to try. But first, we got to do a little bit of housekeeping. Oh, I should mention too that I am nearly done with the problem set 2, so which is actually problem set 3 because, you know, we have to be clever and start with 0 because we're doing programming, right? So if we get through this video, I'm basically 2 problem sets done. 2 problem sets and 1 problem behind. But that's fine because, you know, I try to do those when I have time and I'm not able to stream. So, and I don't want to do those on stream because I don't know about academic integrity and all that nonsense. So I've been doing that off stream on my own time. Before we get started, though, we have to do some housekeeping. I can do this because of this very generous license that HarvardX/EDX has. It could be these videos can be copied or distributed in any format, so I'm able to play them and talk about them as we go through them. Could remix, transform, and build upon the material. I'm trying to build upon things, but we're pretty much already into stuff that I don't know. So the building upon on my end is very limited right now, but we're learning. That's the whole point of this, is to learn. Give appropriate credit down below. There's a link to both this license and to the course. You can go sign up. It's completely free. Get a little certificate at the end once you complete it. You can also pay money to get a validated certificate. You don't really have to do that if you don't want to. I don't plan on doing that. Maybe if I work through all of them and do like the main course, maybe I'll throw some money their way. I'm a poor guy. I'm a poor college student, so money's tight. No commercial material cannot be used for commercial purposes. I'm not monetized. My channel's not monetized. If one day my channel does become monetized, I'll go back and unmonetize these videos. I don't have any I don't have any links to any tip jars or anything. So, if you see any ads, it's not me. It's YouTube. YouTube probably still thinks they need to pay the bills, which I understand. But I'm not getting any money from it. And as far as the license goes, YouTube does apply copyright licenses or whatever to all their videos. But you won't have to worry about me copyright striking or anything like that. I'm not going to do that. I wouldn't do that anyway. So feel free to use my material of me using their material all you want. Don't matter to me. So we were finishing up with sys.exit, going into slices. I backed it up just a few seconds just to get a running start into the next section. Like I said, I'm gonna do my best to get through all of this. We'll just see. I may tap out early, I may not. I'm already feeling pretty sluggish, so I'm gonna try.
4 name tags, whereby the first contains the name of the program itself. Maybe not a big deal, maybe that's the sticker we don't bother handing out, but it's wasteful and it does look wrong. So how could we get access to not all 4 elements of argv, but just a slice
Oh yeah,
of
argv.
This is actually a technical term. In Python and some other languages, to take a slice of a list means to take a subset of it. Maybe from the beginning, maybe the middle, maybe the end. But a slice is a subset of a data structure like a list. Well, how do I actually do this in code? Well, in Python, it's actually very easy to take a slice of a list, that is a subset thereof. You can simply do this. At the end of the list name, sys.argv in this case, you can use square brackets, and then in those square brackets, you can specify the start and the end of the list that you want to retain. I want to start at element 1, not 0. I want to start at element 1, and I want to just go to the end. So I'm actually going to omit a second number altogether. It's not necessary to have a second number, but I do need that colon because this is going to give me a slice of the list. It's going to give me a slice of the list that starts at location 1, not 0.
Okay, if memory serves right, we're getting rid of this first line, hello, my name is name.py. I think that's what he's doing here. By going from 1 to the end, because this would be line 0, this would be line 1, and it'd go through to the end.
0, and the colon, and then a blank just means it's going to give me everything else. So this is equivalently going to slice off the first element of the list and give me a new list that contains just those 3 human names, not the name of the file itself. Let me try running this again. I'm going to run Python of name.py, David, Carter, wrong Shin. This time, hopefully, I'm going to get 3 and only 3 name tags. Hitting enter, and indeed, I've done now just this.
Bingo.
So again, using some relatively simple syntax in Python, we can use square brackets not just to go to specific elements like bracket 0 or bracket 1. We can also get subsets of the list, slices of the list, by doing bracket something colon something, where each of those somethings is a number, the beginning or the end, and they're optional, depending on whether you want all of them or just some. Any questions now on this version, which adds the loop and these slices with that new syntax?
Can we slice starting from the end of the argument vector?
You can. You can slice something from the end of the argument vector, and this might blow one's mind a little bit. Let me go ahead and do this. Let's see. Let me go ahead and do -1 at the end, using a negative number here and running the same command. We've just uninvited wrong Shin from receiving a name tag here. So if you use a negative number, it has the effect of counting to the in the other direction from the end of the list. A good question there. Other questions now on slices, on looping over sys.argv.
Hi. So I remember very early on when we were talking about only having 2 decimal places in an float value. Is that in the same vein? Like because we use the colon point to f. So is that the same thing then? Why would the f be included then in the point to f as opposed to here when you just have the numbers?
A really good question, and it's just, the short answer is that context matters. So there's only so many keys on our keyboard, and so we sometimes use the same symbols for different things. So what you're alluding to is the format code in F-string for actually formatting a number, using a colon, using a period, using a number, using the letter F, and so forth. And that is very specific to the F-string feature of Python. This case has nothing to do with any of that syntax per se. This is just using a colon in a different context to solve this problem, to implement a slice. The authors of Python could have chosen another symbol, but honestly, looking down at my keyboard here, we don't have that many to choose from that are easy to type, so sometimes they have different meanings. A good question as well. Allow me to propose now that we take things further and move away from using only those modules, those libraries that Python comes with, to talk about more generally packages that exist. One of the reasons that Python is so popular and powerful these days is that there's a lot of third-party libraries out there as well, otherwise known as packages. Strictly speaking, Python itself has a term of art called a package, which is a module essentially implemented in a folder, not just a file, but a folder. But more generally, a package is a third-party library that I can install on our own Mac or PC or our cloud server and gain access to even more functionality that other people have implemented for us. Now, one of the locations you can get all of these packages is called the PyPI websites, the Python Package Index, which lives at this URL here, And this is a website that is searchable via the command line as well as via the web that allows you to download and install all sorts of packages. Even CS50 has some of its own packages in services like these. Now there's a fun one out there that's a throwback to a command that's been around for years in command line environments called cow_say. Cow_say is a package in Python that allows you to have a cow say something on your screen. If curious to read up on it, its own documentation is on pypi.org, specifically at this URL here. But how do you actually get the package into your system? Well, technically you could figure out how to download the file and maybe unzip it and put it into the right location on your Mac or PC. But nowadays, a lot of languages, Python among them, has what's called its own package manager. This one here called pip, which is just one. So pip is a program that generally comes with Python itself nowadays that allows you to install packages onto your own Macs or PCs or cloud environment by just running a command, and then voila, you have access to a whole new library in Python that didn't come with Python itself, but now it's available on your system for you. Let's go back to VS Code here, and in my terminal window, I'm going to go ahead and type pip install cow_say. Now what's going on here? Pip is the command, the package manager, and I want to install what package? The package called cow_say. I'm going to go ahead and hit enter here, and after a little bit of output, it has successfully installed cow_say. Now what does that mean? That means I can now go about importing this into my own code. Well, let's go ahead and see what this means. So let me go ahead and create a new file with code called say.py.
I thought that was just part of the video.
I want something to be said on the screen. And in my new tab here, I'm going to go ahead and import cow_say, which presumably is now installed. I'm now going to import sys as well, because I'd like to use some command line arguments in this program just so that I can run it quickly, and without using the input function, I can get the user's name immediately from the prompt. And let me go ahead and do this. I'm going to do a bit of error checking proactively this time, and rather than use less than or greater than, I'm this time going to say if the length of sys.argv does equal 2. So if the human is provided just the name of the program and their own first name, we're good to go. I'm going to do the following. I'm going to call a function called cow in the package called cow_say, and I'm going to pass in a string, hello, comma, and then, as in the past, I'm going to pass in just one string, because according to its documentation, it's not like print. I can't pass in comma this, comma that. I can only pass in one string, so I'm going to concatenate the contents of sys.argv bracket 1. So long as then I type in my name, David, after the name of this program, it should end up in sys.argv1, in which case this line 5 of code should concatenate hello with my name, with a space in between, and apparently a cow is going to say it. So let's see what happens here. Let me go ahead and clear my screen and increase the size of my terminal window. Let me go ahead and run python of say.py and type my name, David, and enter. There is the program called cow_say. It literally has a cow say something on the screen. And
the cow_say,
this is a throwback.
Got that in Python too. I'm sure Windows probably has something similar to that as well.
To a program from yesteryear that tended to come with a lot of systems. This is otherwise known as ASCII art. It's a textual way using just keys on your keyboard to print pictures of sorts on the screen. Now we can really go down the rabbit hole here, and there's questionable academic value of doing so, so I'll do so just once.
There's a lot of academic value, thank you very much.
Turns out the cow_say package comes with other functions as well. One of those functions, for instance, is T-Rex. And if I now increase the size of my terminal window, we'll perhaps see where we're going with this. Let me now run again, python of say.py. This time, let me not provide my name just to see if it's broken. It's still okay, because we have that if condition. If the length of sys.argv equals 2, and only if it equals 2 do we do anything. That's why we're not seeing anything here. Let me go ahead and cooperate now. Say.py space David, and it's no longer a cow, but if I zoom out on my screen, a T-Rex. Why? Just because. These are the things you can do once you know how to program. You can even package them up and make them freely available to others as open source software. For us, it's demonstrative of a feature more generally here, namely being able to install these third-party packages and how you might do so in Python. Now, I'll leave this up on the screen for a moment and see if there's any questions about cows or Tyrannosaurus rexes or packages more generally. I'm really qualified to speak to just one of those.
Hi, I've got two questions. It's a bit earlier than what it's supposed to be. So the first question is the packages that you're calling um, to use in the program. Are they the same as, let's say, because I'm doing Java, um, the same as calling a class of a Java file in order to use its functions? And my second question is, what's the actual purpose of using command line arguments as you have used? Because it's not really the best way to, as you say, be user friendly. Where, as in, let's say the person who's using the program doesn't know what they want, what the program's asking them.
Really good questions. The first question about the comparison with Java. Python packages are similar to Java packages, where you have something dot something dot something at the top of your program that gives you access to a class or something else. Python itself supports classes, more on those down the road, and you can do very similar things in Python as you can do with Java. But the analog really is Python packages to Java packages here. As for command line arguments, you ask a good question. Why do we use them, especially if they're a little less user-friendly? They're a little less user-friendly to people who aren't in this Zoom, to be honest. You and I, as we learn more and more about programming and more about command line arguments, I dare say will become more comfortable with and tend to prefer the ability to customize commands using these command line arguments. Why? Productivity. It tends to make you faster because you get into the habit of knowing exactly how you can configure your software without having to manually answer questions. And case in point, all of this time have we been running Python of something.py. You could imagine not doing that. You could imagine typing only Python, hitting enter, and then you're prompted for the name of the file you want to run. So you type in something.py, and then it runs. Not a big deal, but I would argue that over time, you're going to get a little tired of that tedium, and you would much prefer to just automate the command again and again and again, especially with little conveniences like being able to hit up and down in your keyboard history so as to rerun those same commands. Automation is big too. If you emerge from a class like this and start using Python to automate processes at work or for personal projects or the like, the ability to specify all of your inputs on the one line just means you can get work done more quickly. So hands down, absolutely, using command line arguments is a more arcane feature of systems that most of us are no longer as familiar with because of Windows and Mac OS and other operating systems that have buttons and GUIs and menus. But the more comfortable you get with programming, I dare say the more you will tend to prefer these capabilities because they allow you to do things more quickly. With that said, allow me to propose that we take a turn toward yet another package that's particularly popular and just as easy to install, all toward an end of using APIs. Now, APIs are not something that's Python specific. More generally, an API is an application programming interface, and it can refer to Python files and functions, but often APIs really refer to third-party services that you and I can write code that talk to. Many APIs, but not all, live on the internet these days, so that so long as you have a browser or so long as you have some experience with Python programming or programming in any language, you can write code that in effect pretends to be a browser, connects to that third-party API on a server, and downloads some data that you can then incorporate into your own program. Now, how do you do this? Well, Python has a very popular package that you can install via pip called requests. The requests library allows you to make web requests, internet requests, using Python code, essentially as though you were a browser yourself. You can automate, therefore, the retrieval of URLs that start with HTTP or HTTPS. The documentation for this library is at a URL like this, but it too can be installed at the command line, and even though it's third party, it's one of the most popular and commonly used packages out there in Python, and this too is one of the reasons, again, that Python is so popular. There's just so many solutions to problems that you and I have or are invariably going to have when we write projects of our own. There's just a really vibrant ecosystem, a really vibrant community of open source software that's that easy for us to install. Let me go back to my terminal window now and run pip install requests in order to install this package on my own system, and after some lines of output, I'll see that it's successfully installed. Now let's go ahead and create a new file here. For instance,
I should probably do that. Maybe.
popular. There's just so many solutions to problems that you and I have or are invariably going to have when we write projects of our own. There's just a really vibrant ecosystem, a really vibrant community of open source software that's that easy for us to install. Let me go back to my terminal window now and run pip install requests in order to install this package on my own system, and after some lines of output, I'll see that it's successfully installed. Now let's go ahead and create a new file here, for instance, itunes.py. It turns out that Apple has its own API for their iTunes service, the software that provides you with the ability to download and search for music and songs and other information as well. And it turns out that, let me go back over to my computer here and open up a browser like Chrome, and let me go ahead and visit this URL here, https://itunes.apple.com/search, !entity equals song, limit equals 1, term equals Weezer. Now, I constructed this URL manually by reading the documentation for Apple's API, Application Programming Interface for iTunes, and what they told me is that if I want to search for information about songs in their database, I should specify entity equals song, so that it's songs and not albums or artists or something like that. If I just want to get back information on one song, I'm going to provide limit equals 1, and if the band I want to search for, the artist, is Weezer, I should specify term equals Weezer. So with this, if I go ahead and hit enter and visit this URL, I actually end up with a text file in my downloads folder on my Mac. If I go ahead and open that text file that my browser just downloaded, we'll see all of this text here, which at first glance might look a bit cryptic, but it actually follows a pattern. Notice this curly brace at the start, and notice this closed curly brace at the end. Notice this open square bracket here, and notice this closed square bracket here. And in between those pieces of syntax are a whole bunch of strings and values. In fact, a whole bunch of key value pairs. What we're looking at here is a standard text format known as JSON, JavaScript Object Notation, which, yes, is technically related to yet another programming language called JavaScript, but JSON itself is typically used nowadays as a language-agnostic format for exchanging data between computers. By language agnostic, I mean you don't have to use JavaScript. You can use Python or any other language to read JSON or write it as well. And it's a completely text-based format, which means that if I visit that URL with my browser, what gets downloaded is just a bunch of text, but that text is formatted in a standard way using curly braces and square brackets, using quotes and some colons that ultimately contains all of the information in Apple's database on Weezer's song, at least the first one, because I limited it to one, in their database. And that's an API, an application programming interface, a mechanism whereby I can access data on someone else's server and somehow integrate it into my own program. Now, of course, my browser, Chrome, is not something I wrote. I should actually write some Python code that perhaps pretends to be a browser to grab this same data. So let's do that. Let me go back to VS Code here, and let me write a program with code itunes.py. And we're going to write some code via which I can then use the iTunes API and in turn Python to get information about any band that I might want. I'm going to go here and import first the requests library, which I installed earlier in order to make those HTTP requests. I'm going to go ahead and import the sys library, via which I'll have the ability to use command line arguments like specification of the band that I want to search for, if not Weezer. And then down here, I'm going to go ahead and insert some error checking to say if the length of sys.argv does not equal 2, so if the user does not provide me with the name of the file they want to run and the name of a band, and that's it, you know what, let's just go ahead and exit for now. I could provide a more explanatory message, but for now I'm going to keep things simple and just exit the program prematurely so that I can trust hereafter that sys.argv has what I want. And now I have the opportunity to use the requests library to write some Python code that effectively is pretending to be a web browser so as to connect to that same HTTPS URL on Apple's own server. So now that I've guaranteed that the user has typed in not just the name of the file, but also the name of a band at the prompt, giving me a length of 2 for sys.argv, let's go ahead and execute requests.get, which is a function inside of the requests package that will literally get some response from a server, and the URL that I want to get is exactly the same as before, https://itunes.apple.com/search, !entity equals song, limit equals 1, term equals previously Weezer, but let's make this program a little interactive and actually allow the human to specify at the command line what artist they'd like to search for. So I'm going to go ahead and close my quote early and just append, using the concatenation operator as in the past, sys.argv bracket 1. And now, it'd actually be nice to store the response from the server in a variable. So I'm going to go ahead and say response equals, and to store all of the response that comes back from the server in a variable called response. Down here now, I'd like to just understand what the server's returning to me to make sure I know how next to proceed. So this isn't going to be very pretty yet, but I'm going to go ahead and print out response.json, which ensures that the data I'm getting back is formatted on my screen as exactly that, JSON. The same text format as we saw on my screen. It's not a useful program yet. I'm really just learning along the way, but let me go ahead now and increase the size of my terminal window and run Python of itunes.py and type in the name of a band like Weezer and hit enter. And what we see on the screen, formatted almost the same as before, is exactly that same text. But what you'll see here is that this has been standardized now as a Python dictionary. What indeed Apple's returning is technically a JSON response, JavaScript object notation, but Python, the request library, is converting it to a Python dictionary, which happens to use, wonderfully coincidentally, almost the same syntax. It uses curly braces to represent the dictionary here, and a closed curly brace to represent the end of it here. For any lists therein, it uses a square bracket here and a closed square bracket down here. It uses quotes, single quotes in this case, or equivalently double quotes to represent the keys in that dictionary. And after a colon, it stores the value of that key. And so you'll see that indeed we have a result count key whose value is 1, but then a more interesting results key called results, whose value is this entire list of data. Now, honestly, this is such a big blob of text that it's going to take me forever to wrap my mind around what I'm seeing. So let me propose temporarily we use another library in Python that will allow me to format my data a little more cleanly. It turns out that Python also comes with a special library called JSON that allows you to manipulate JSON data and even just print it. That is formatted in a way that's going to be way easier for you and I to understand. So let me go back to my code here. Let me shrink my terminal window, and let me propose that just temporarily, again, we do this. Let me import this additional library JSON, which comes with Python, so I don't need to install it manually with pip. And let me go ahead now and not just print out response.json, which was that big blob of hard to understand text. Let me go ahead and use one other function here called json.dumps for dump string, and pass to that function that response.json return value. So again, I'm just introducing another function who I claim it has a purpose in life of pretty printing, nicely formatting on the screen the exact same information. And I know this from the documentation, having done this before. But I'd like things to be nicely indented, and according to the documentation, if I pass in a named parameter of indent equals 2, that's going to indent everything at least 2 spaces. I could do 4 or something else, but it's going to be enough to help me wrap my mind around what the data is I'm getting back. Because again, I'm just learning along with you. So let me increase the size of my terminal window again. Let me run Python of itunes.py, and again, let's search for Weezer and hit enter. And now notice it's still a little bit cryptic because there's a lot going on here, but my gosh, I can totally read this more easily now. Notice now that I still see the first curly brace, which means, hey, this is a dictionary in Python, a collection of keys and values. The first key is called result count. It happens to be displayed in double quotes now, but that's just an issue of formatting. It could be double or single so long as we're consistent. The value of that key is 1. Why? Well, I told the URL to only limit the responses to 1 Weezer song, so I've gotten a result set of 1. If I increase that limit, I could probably get more. Then the interesting part of this response is really the data itself. Notice in the results key here, there's a really big value. The value is a Python list, as implied by this square bracket. What does this list contain? Well, I know from skimming it earlier that this contains 1 dictionary, and that's why we see another curly brace here. So again, if this gets a little more complicated, keep in mind that a dictionary is just a collection of key value pairs, and Python uses curly braces to indicate as much. It is perfectly reasonable for a dictionary to be inside of another dictionary if the value of some key itself is another dictionary. So this is a common paradigm, and even though it might seem a bit cryptic, it's just something that allows us to associate more keys with more values. Now, most of this information I probably don't care about. For instance, according to Apple, the unique identifier for Weezer is apparently 115,234. That might be useful if I'm making my own database and I want this to be searchable, but for today's purposes, all I care about is the name of the track, otherwise called track name as key. And the first song, and only song, because we limited it to one, that we got back from iTunes here is the song that you might know by Weezer called Say It Ain't So. So now I have a bit of a clue. If my goal here is to implement a program called iTunes.py that doesn't just dump the response from the server, which is admittedly very cryptic, but to print out all of the songs that iTunes has for the band called Weezer, maybe I can iterate over this somehow. So let me backtrack. Here's the key called track name. It is inside of a dictionary that is the value of results here. So how can I go about getting this? Well, let me go ahead and try this. Let me go ahead and shrink my terminal window back down, and let me propose now for one final flourish. We don't just lazily print out the contents of that response, because that's not interesting or pretty for anyone. Let's do this. Let me go ahead and create a new variable, just for the sake of discussion, called O for object, and I'm going to go ahead and call O equals response.json, just to store that JSON response specifically in a variable called O, but I could name it anything I want. And now I'm going to do this. For each result in that object's key called results, go ahead and print out that result's track name. And notice I have used exactly the same capitalization. Track name has a capital N. Results is all lowercase. And let me rewind before we run the actual program. In line 8, we are making an HTTP request using Python to the server, just like you and I as humans type URLs into a browser and hit enter. This is the Python equivalent thereof. I am then on line 10 just grabbing from that variable that contains the server's response the JSON object that I care about, the thing between those curly braces at the very top and the bottom. But because we've poked around and because I read the documentation earlier, I know that that object has a key called results. And that results key, again, is a list. Now, at the moment, that list contains only one song, Say It Ain't So, because I limited my response to one. But even so, my loop will work. It's just going to iterate once. And each time through that loop, it's going to print the current results track name. If I want to make this even more interesting, let me change this limit now from 1 to 50, so I'll at least get back 50 track names instead. Let me go ahead now and increase the size of my terminal once more, and go ahead now and run Python of iTunes.py, searching again for a band like Weezer. And here we go. And voila, there are 50 songs that iTunes has for Weezer. And if we scroll back up to the top here, we'll see that the very first one there is indeed Say It Ain't So, but now we got Undone, the Sweater Song, Buddy Holly, apparently another rendition of Say It Ain't So, perhaps from another album, another Buddy Holly, Undone, My Name is Jonas, and so forth. Questions now on this program, which integrates Python with a real-world third-party API.
Yeah, hi. Can we?
So I know it's kind of quiet through that. My brain was spinning. Because, like, for my daily job, I have to go out and get prices to price commodity stuff. And I'm just wondering, like, I wonder if I can write, like, a Python program. Like, I don't know if there's JSON files or not. I don't know. But anyway, if I can write a program that will just go out and get the commodity prices for me, and then I can apply it to the formulas that I need. So I'm wondering, like, if I don't know, like I said, if there's like files out there, but even if I could figure out how to do it by just using the HTML. I wonder if that's a thing. I'm going to have to look into that. Mental note that will instantly forget. Like, I mental note that.
Use break instead of system.exit.
Good question, but no. Break, again, is used to break out of things like loops, like we saw earlier. Sys.exit is used to break out of the whole program itself. Use break for loops for now, and use sys.exit to terminate the whole program. Good question. Other questions now on this program or others?
From where we bring the name of the key results?
From where do we get the name of the key?
Results itself. يعني can we change the results name?
You cannot. So we could in our program. So the keys that come back in that JSON response, to be clear, come from itunes.apple.com. Some engineer, some team of engineers decided for us what all of those keys would be called, including track name, results, result count, and everything else. You and I can absolutely store those same values in variables, just like I'm doing here with O, just like I'm doing here with result. You can rename those keys anything you want using Python variables, but the JSON response is coming from that third-party server. Other questions?
Yes, sir. So I have a question related to cowsay package. So like, yes, sir. So sir, what sort of ASCII graphics is it capable of outputting?
The cowsay package. I would refer you to the URL in the slides earlier, if only because it's more thorough. They have not just cows, but Tyrannosaurus rexes and several other animals as well. I should emphasize that this is not a package I suspect you will use much in the real world. It's really just meant to be representative of the types of packages you can install, but allow me to refer to the documentation for what more is there. But ASCII art is all we had before there were emojis, let alone GIFs and JPEGs and pings, but it's what is immortalized in cowsay. Well, allow me to transition us back now to one final capability of Python, which is that you yourselves have the ability to make your own libraries. Up until now, we've been writing all of our functions in our one file, hello Py and everything since. And now that we've introduced modules in Python, like random and statistics, we can import those that come with Python, but that's other people's code as well. And we've now used pip, this package manager, to install third-party packages as well in the system, and using other people's code still. But to come full circle, what if you yourself find yourself implementing the same kinds of functions again and again? Or you find yourself opening up old programs, copying and pasting code you wrote into new programs because you have the same problem yet again. A good practice would be to somehow bundle up that code you keep reusing and make your own Python module or package. You can keep it local on your own Mac or PC or cloud server, or you can go through the steps of actually bundling it up, making it free and open source, and putting it on something like PyPI for others to use as well. Okay, I'm going to go ahead and run code of sayings.py to create a brand new file called sayings.py, which is going to be my own sayings module. I'm going to define a couple of simple functions in there. I'm going to define a hello function that's going to take a name parameter as input, and that function is simply going to print out an F string that contains hello, comma, and then in curly braces, whatever that person's name actually is. Then I'm going to go ahead and define one other function, a goodbye function, that has def goodbye, also takes a name as its input, and then that prints out by contrast an F string that says goodbye, comma, and then in curly braces, name. And now, just for good measure, just so I can be sure that these functions are working as expected, I'm going to go ahead and define a main function in here too, just for the purposes of testing. And I'm going to go ahead and define a main function that simply does a couple of tests. For instance, it calls hello of quote-unquote worlds, shall we say, and then it's going to call goodbye of quote-unquote world as well. And hopefully what I'll see on the screen then is hello world and goodbye world when I run this program. Of course, as always, I need to explicitly tell Python to call that function, so I'm going to call main at the very bottom of this file. All right, let's try it out. Python of sayings.py, enter, and indeed I see hello world and goodbye world, and so I think it's reasonable for me to assume that these functions, albeit simple, are pretty correct at this point. But now suppose that I want to use these functions as though I've indeed created my own library, my own Python module that makes available a hello function for me or anyone else who wants to use it, or a goodbye function as well. Well, let me go ahead and open up again say.py, but start fresh. And rather than have the cow say anything, let me go ahead and have my own library do the talking. So I'm going to go ahead and, as before, import sys so that I have access to command line arguments. And from my own module called sayings, I'm going to import hello. So because I created a file called sayings.py, I can say from sayings, and it's inferred by Python that I mean sayings.py, at least in this current directory, but I specifically am going to import just one of the functions for now, namely hello. And now I can do something like this. If the user obliges by giving me 2 command line arguments, which I can check by just checking the length of sys.argv, I'm going to then go ahead and call this new hello function, passing as its input sys.argv bracket 1, which should hopefully be the person's name, which I'm going to expect them to type at the prompt. So here we go. I'm going to go down to my terminal window, run python of say.py, and my own name, because I want my own name to end up in the command line arguments and therefore be part of the hello. So when I hit enter in just a moment, I should hopefully see hello, comma David. So here we go, enter, and I see hello world, goodbye world, and then I see hello David. So why is this happening? Well, it turns out, even though I've done everything according to our own past practice, it's not really the right way to go about calling main after all. If I'm blindly calling main here at the bottom of my file, that means whenever this file is loaded by Python, main is going to get called. And unfortunately, that's true even if I'm importing this file or just a function from this file as I am here in my say.py program. This is to say on line 3 here, when I say from sayings import hello, this effectively tells Python to go find that module, sayings.py, read it from top to bottom, left to right, and then import specifically the hello function. Unfortunately, by the time Python has read the file from top to bottom, left to right, that last line of code recall is to call main. Main gets called no matter what. So really the right way to go about using a main function, which does solve that problem of ensuring that we can order our functions however we want and all the functions will be defined at the time they're invoked, I shouldn't be unconditionally calling main at the bottom of this or really any of my programs. I should instead use this technique. I should say if underscore underscore name underscore underscore equals quote unquote underscore main underscore close quote, then and only then should you actually call main. Well, it turns out that this
I knew he was getting to, but I forgot it was underscore name underscore
variable is a special symbol in Python. Underscore name underscore, and notice that VS
actually was using that in a problem set that I did. So I don't know why. Yeah, I don't know.
Code, because of its font, isn't quite showing those 2 underscores, but they're indeed there to the left and the right. This is a special variable whose value is automatically set by Python to be quote-unquote main when you run a file from the command line, as by running python of sayings.py. So watch what happens now with this additional conditional in sayings.py. If I run python of sayings.py, it still works as before, because name will be automatically set to underscore main underscore when I run this file using python of sayings.py. But notice this, name is not going to be set to quote unquote main. It's going to be set to something else, technically the name of the module, when I instead import the file like I do here. So this highlighted line of code, even though it will cause Python to go find sayings.py, read it from top to bottom, left to right, it's going to ignore the call to main this time because it's wrapped in that conditional. In this case, when I'm importing a file and not running it directly at the command line, main will not get called by definition of that name's value. So let me go ahead and try this. Instead of running python of sayings.py, which is the module which contains that conditional main, let me go ahead here run python of say.py, which is the program here before me that imports hello from sayings. But because of that conditional, it's not going to say hello to anyone else except me, in this case. All right, we're here at the end of our week. It's only appropriate, I think, to import something other than hello. Why don't I go ahead and import not hello, but goodbye from here? Let me go ahead and call goodbye instead of hello. And this time when I run python of say.py, I'm not going to type my own name. Allow me, if I may, to type in the whole world so that our final sentiment today is goodbye world. Indeed, that's it for this week. We will see you next time.
All right, we made it. I barely made it, but I made it. Just out of curiosity here, I want to take this off for a second. Oh, let me wrap this up with the housekeeping. We gotta watch this on this stream because of the generous license that HarvardX EDX does. where I can copy and redistribute the material in any way. So can you. You can use this material that I'm doing right now if you really want to. YouTube does put copyrights on the stuff that we upload, but you don't have to worry about me copywriting striking anybody. You're free to use this all you want. Can transform, mix, build upon. I know I didn't build upon nothing. I think we're going to be out of my knowledge base. We were out of my knowledge base a while back. We're really out of my knowledge base now. There's a link down below where you could sign up for this class through EDX and HarvardX and whatever. There's also a link to the license down below too. But anyway, it's a free program, so you can you can sign up and do the problem sets and get a little certificate at the end. You get a validated certificate if you want. You don't have to. It costs money, but this stream is not monetized. My channel is not monetized. For some reason, my channel does become monetized. I'll go back and unmonetize these videos. There's no links to any tip jars or anything like that. If you see any ads, it's YouTube. It's not me. And yeah. So what I want to do real quick, I'm going to look up where my prices come from, because I never paid attention as to if there's like let's see if I can find it. Let's just do let's type in that. Let's see if I can find it through this. Here we go. Let's see. What do I want here? I want the there's the cutout. If I click on this. Okay, so that's an XML file. But if I can get JSON format API, boom, right there. This is what I'm looking at. So theoretically, I could import this file into a Python program. Interesting. I'm going to play around with this for a few minutes before I go to bed. I want to end the stream here. Thank you for anyone that's tuned in. Please like, subscribe, share, all that noise. If you enjoy this sort of a thing, I know it's probably not the most entertaining content in the world, but I'm trying to learn, and that's the main goal is to learn. So if you like learning, you can learn with me, and if you don't like learning, then you're probably in the wrong spot. So you're probably in the wrong profession too, because you always have to be learning and upgrading. So